Hello. This lesson will focus on fraction readiness skills. So before we try to solve 1/2 plus 3/7, what skills do we need before we try to do problems like this and like this? Okay? Now, the first skill we always need is how do we reduce? Okay? And so we always find the biggest number that can go into both top, the numerator, and bottom, the denominator. Now, 2 goes into both of those once and twice, so 2/4 reduces to 1/2. And another word for reduce is also simplify. Simplify or simplifying. Okay? 3 and 9. 3 goes into top and bottom, so we get 1/3. Now if we come over to 5 and 9, 5 cannot go into 9. There's not another number besides 1 that goes into them, so that's already simplified or reduced. Okay? Now sometimes when the numerator is bigger, we'll get a little different type of answer. 7 goes into both of those, 2/1, and then that comes out as 2. 27/3. 3 goes into top and bottom, 9/1, which is equal to 9. 3 and 7 are both prime numbers. No number goes into them evenly because they're prime, except for 1. So that stays as simplified. Okay, 5 and 15. 5 goes into the top ones. 5 goes into 15. 5/15 becomes 1/3. Let's reduce. Ooh, watch this. 10 goes into 10. 10 goes into 40. 1/4. Or you can just cancel out those zeros. And 10 and 13. There's no number besides 1 that can go into them, so that is reduced. Okay, so just real simply, 5 goes into there, 3/4. We look for the biggest number that can go into both of those, and that happens to be 2, so that goes to 9/10. 24/30. Let's say we're not too sure, and we put 2 into that, and that's 12/15, but 3 can still go into those, 4 and 5. So if we actually take the first time we reduce by the second, and then we multiply them, we get the biggest number that would have gone into them. Now watch, 24 divided by 6 is 4, and 30 divided by 6 is 5. So we could have started out dividing by 6 at the very start. 12/15 divided by 3, and we get 4/5. 35/42. Now what goes into those two things? 6? No, 6 doesn't go into 35. 7 does. So we get 5/6. 18/30. Is 2 the biggest number? No. How about 3? No. How about 5? 5 doesn't go into 18. Nope, 6 does. 3/5. 14 and 27. Well, 14 is 2 times 7. 27 is 9 times 3. There is no number besides 1 that goes into both top and bottom, so that is reduced. That was kind of hard. 14/20. 2 goes into those, 7/10. Now 14/21, all we did was increase this by 1, but 7 goes into both of those, 2/3, 2/3. Now when the top matches the bottom, that's equal to 1. 11 parts out of 11 parts is 1 whole. Woo! What's the biggest number that goes into here? Is it 5? No, it's 25. Goes 1 1/3. This is kind of like 1/4 over 3/4. Okay? Now here, What's the biggest number? 2? No. 3 goes into both of them, but that's not the smallest. 6 goes into both of them. How about 9? No, 9 can't go into this one. It's 12. Think of 2 dozen eggs over 3 dozen eggs. Now watch out here. Lots of kids, they look at 15 and 45 and go, 5. I'm confident that's right. And they get 3 9s. But then they don't reduce that. Okay? Well, 3 9s you can reduce by 3. And so we get 1/3. So watch this. If we take 5 times 3, we could have initially divided by 15. 15 divided by 15 is 1, and 45 divided by 15 is 3. 14 over 70 is another tricky one. We say, hey, 7 goes into those, and then we get 2 over 10. And then we say, that's our answer, but it's not reduced, okay? So if we reduce that by 2, we get 1/5. Now, we originally could have divided by 14. 14 goes into 14 once. 14 goes into 70 5 times. 1/5. Okay? Now, our next skill that we need to know is to understand the difference between proper fractions versus improper fractions. Now, proper fractions are supposed to have a smaller numerator and a bigger denominator. Whereas improper fractions, they're bigger on top and smaller with the denominator on bottom. Mixed numbers, they have a whole number out front, and then they have a proper fraction right there. Whole number, fraction, mixed numbers. Now often when we deal with adding, subtracting fractions, we have to convert improper fractions to mixed numbers. Okay? Now, how might this work? We ask ourselves, how many times does 2 go into 3? Once. 2 goes into 3 once. 2 times 1 is 2. We subtract. We get 1, and we always bring the denominator over just like this. Okay? How many times does 5 go into 9? Once. Now, 1 times 5, we subtract that. We get a remainder of 4, and we bring that denominator up here. 3 goes into 5 once, and 5 minus 3 is 2/3. Okay? All right. 7 goes into 10 once. There's 3 remaining over 7. 4 goes into 7 once with 3 remaining, 4ths. And 10 goes into 11 once with 1/10 remaining. Okay? Now, those are easy because they all ended up with a whole number of 1. But sometimes, well, most of the time, we get a higher whole number. 5 goes into 11 twice. 5 times 2 is 10. We have 1/5 as our leftover. 5 goes into 17 3 times. 3 times 5 is 15. So we get 3 and 2/5. 2/5 as the leftover. 4 goes into 17 4 times with 1/4 as the leftover. 8 goes into 25 3 times, and we know that's 24, so there's 1/8 left over. 11 goes into 25 twice. 2 times 11 is 22. We have 3 11s there. 7 goes into 50 7 times with 1/7 left over. Now, sometimes things can get a little tricky when we're given a improper fraction and we got to convert, but then we have to reduce. Let's look at 22 over 10. Let's say we first take 10 into 22 is 2, and then we have 2/10 left over. Well, 2/10 can be reduced to 1/5. Now, some teachers may teach 22 over 10, reduce this first, divide by 2, and we get 11 over 5, and there is 2 1/5. So those answers match up. We just did them a different way. Let's look at 12 over 8. 8 goes into 12 once with 4/8 left over. 4 can go into both of those, 1 and 2, so we have 1 1/2. Now, some people might be taught 12 over 8, take 4's out of there, we get 3 over 2, and that's 1 1/2. And 30 over 12, 12 goes into here twice with 6/12 remaining, and that's 2 1/2. Other people might say, what number goes into 30 and 12? 6. And so this is 5 over 2, which is 2 1/2. And lastly, 25 goes into 30 once and 5/25. Divide those by 5, we get 1 1/5. Somebody else may go 30 over 25. Divide that by 5, we get 6/5, which is 1 1/5. Okay? Now the last skill we're going to need is just the reverse. We're going to convert mixed numbers to improper fractions. Okay? All right. First of all, take the denominator, and that always is the same. And then all we have to do is take our whole number and times it by our denominator, and then add the 2. Okay? So, oops. All right. I guess I made a mistake there. So we take 1 times 7 is 7 plus 2 is 9 over 7. Okay, I guess I made a mistake. Then we take 3 times 3 plus 1 is 10 over 3. Now, 4 times 5 plus 1 is 21. Keep the same denominator. 8 times 2 plus 1 is 17 over the same denominator. See, I'm making no mistakes now. 5 times 8 is 40 plus 3 is 43 over 8. 2 times 12 is 24 plus 1 is 25 over 12. 4 times 7 is 28 plus 3 is 31 over 7. 1 times 2 is 2 plus 1 is 3 over 2. 1 times 3 is 3 plus 2 is 5 over 3. 3 times 4 is 12 plus 3 is 15 over 4. 5 times 4 is 20 plus 1 is 21 over 4. 8 times 10 is 80 plus 1 is 81 over 10. And last but not least, 1 times 5 is 5 plus 4 is 9/5. And 2 times 11 is 22 plus 4 is 26 over 11. And there we have some basic skills before we get into fraction operation.